Hello everybody, welcome back to another episode of Chemistry Explained in Minecraft. Today I'm going to be talking about ionic bonding. Now I don't know if I mentioned this in a previous video, but there is something called the octet rule in chemistry, okay? This is a key term, the octet rule. And it basically stipulates that every element will want to have a full outer shell. Now what do I mean by that? Well, let's see. Right now I am an element. I have electron configuration 1s2, 2s2, 2p6, 3s2, 3p5. Ooh. Now if we go to our periodic table, you can see I am chlorine 1s2, 2s2, 2p6, 3s2, 3p5, sorry. Now I am one electron away from just becoming one of the noble gases, and filling up this shell. And that's the octet rule in action. Every element wants a full outer shell, which is generally 8 electrons, or is always 8 electrons. So I'm chlorine and I really badly want one extra electron, and ooh, what's that over there? It's an electron. Gimme, gimme, gimme. And that's exactly what chlorine does. It wants its electrons so insanely badly. But now let's say I am let's say I'm another element. Let's say I am sodium, which I will run over here and show. This is sodium. 1s2, 2s2, 3s1. If you go back to the periodic table, that is sodium. Now, sodium wants an electron. Now, sodium, it doesn't want to get 7 more electrons. Who's going to give it that? So it'd rather just lose this one. It'd rather just lose it than get more electrons. Now you may be wondering, wait a minute, but that means this outer shell isn't filled. Well, yeah, but the shell no longer exists. This is the outermost shell. And oh my god, it's filled. Now, what does this mean for the charge of an atom? Well, in chlorine's case, it still has the same number of protons as it always has, 17. That's just how chemistry works. The amount of protons determines a chemical element, or determines an element's identity. But because the number of protons aren't changing, but the number of electrons are changing, that means the atom now has a charge, and it's no longer called an atom. It's an ion now. Atoms are neutral, ions are charged. Because chlorine gained an electron, it now has a negative charge and is a negative ion. Sodium here, meanwhile, has lost electrons, so it is a positive ion. And you can lose more than one too. For example, let's say this was magnesium now. Magnesium would also just decide to lose 2 electrons instead of gaining 6. And the same thing holds true for negative ions. Oxygen would rather just gain 2 than lose 6. And now let's say a sodium and a chlorine a sodium atom and a chlorine atom meet. Well, chlorine wants an electron. Sodium has an electron to give. So the two decide to make a deal. Sodium, you give me your electron. You will be happy. I get my electron. Ooh, I am happy. Let's bond. And sodium says, sure, why not? And it goes through. Chlorine gains its atom. Sodium loses, chlorine gains an electron, sodium loses its electron, and boom, we now have a bond. Now the charges of the ion and the charges of the other ion have to be matched. For example, if this was magnesium and I am a chlorine atom, I can't just walk up to magnesium and say, "Oh hey, give me your 2 electrons." "Wait, but you only have 1 spot," says magnesium. "Yeah, that's true." "Yeah, no, I'm not bonding with you. Either get another chlorine in here, or don't bother talking to me." So 2 chlorines can bond to a magnesium because the chlorines can say, "Okay, yeah, sure, here." Or, sorry, magnesium can say, "Okay, here. Here's 1 electron for you, and here's 1 electron for the other you." So you can get a compound such as MgCl2. Now, let's just do a quick little quiz. 1s2, 2s2, 2p6. What are 4 ions that could make this? Well, first, what element is this? Well, 1s2, 2s2, 2p6. This is neon. Now, what elements would want to become more like neon? Well, the ones surrounding it. That would be oxygen, fluorine, sodium, and magnesium. Because remember, sodium has the same electron configuration as neon, plus 1 extra. Same likewise for magnesium. So what ion would they form? Well, oxygen needs 2 electrons, so it becomes O2-. Fluorine needs 1 electron, F-. Sodium will lose 1, so Na+, positive. And magnesium will lose 2 electrons, Mg2+. Generally, the ones on the left here, they will lose 1 electron, 1 or 2 electrons, and that's why they are metals. The ones on the right here are nonmetals, and they will want electrons. And ionic bonding, which is what sodium chloride is made of, magnesium chloride is, they will generally occur between metal and nonmetal. Now you may be wondering, okay, well, what about hydrogen? Is it an ion? I don't think it's not non-metal according to the periodic table. So then what does it do? Well, this can actually do ionic bonding. You see, hydrogen is so small that any other element will just take its electron. Sometimes it stands up for itself and is like, no, we must share. And that's covalent bonding, which I'll explain in the next episode. But occasionally it will actually bully another element, for example with sodium hydride. Let's just search that up. Hydride. Sodium hydride. Yep, H- ion. But that is very rare and generally doesn't happen. I hope you enjoyed this explainer in ionic bonding. I'll see you in the next video where I talk about covalent bonding. Bye! Oh, and by the way, if you have any suggestions, please drop them in the comments below. Any suggestions, clarifications, improvements I can make, it would all be very appreciated. And don't forget to like this video and subscribe to the channel. Thank you! Sorry.